Hello, myself Saurabh Noskor, Assistant Professor of Chemistry at Gargi Memorial Institute of Technology. In my previous lecture, I discussed about organic chemistry. Today I will discuss periodic properties. First, I will start with a question: what is skinning constant? See this picture. Here, the electrons present in the valence shell are attracted by the positively charged nucleus. Okay, while there is a repulsion between this valence electron and the electrons present in the inner shell. There will be repulsion between this inner orbital, inner electrons and valence electrons. So, due to this, there is a decrease in the force of attraction between the electrons in the valence shell and the nucleus. For this repulsion, there will be decrease in the force of attraction between this one, and this effect is called skinning effect. And skinning effect can be understand by calculation of skinning constant. This is your skinning constant. Okay. Then we have to calculate effective nuclear charge. Effective nuclear charge can be calculated by the formula Z star equal to Z minus sigma. Here Z is your atomic number and sigma is your skinning constant. And for iron having atomic number 26, we can write electronic configuration in this way: 1s, 2s, 2p, 3s, 3p, 3d, 4s. 1s having 2 electrons, 2s having 2 electrons and 2p having 6 electrons. So total there will be 8 electrons. 3s having 2 electrons, 6 electrons, so 8 electrons, 6 electrons and 2 electrons. But we have to group in this way. Here s and p orbital will be in one bracket and d orbital will be in another bracket. Then for calculation of sigma, you have to know this table. See this one. Here, if an electron is present in n cell, means this one, then its contribution will be 0.35 per electrons. N cell means this one. This is your n minus 1 cell. This is n minus 2 cell. There will be n minus 3 and so on. So for n cell 0 minus 35, for n minus 1 cell contribution is 0.85 per electrons, and if an electron present in n minus 2 or n minus 3 and onwards, then its contribution will be 1. This is valid for calculation of s and p electrons, and this table is valid for calculation of Z effective of d and f orbital. If an electron is present in n cell, contribution will be 0.35, and for onwards n minus 1, n minus 2, n minus 3, all for contribution will be 1. Okay, let's see one example. First one, here we have to calculate effective nuclear charge. So this is the rule for calculation of effective nuclear charge. Here you know atomic number, means Z is given 26, so you have to first calculate this skinning constant. Then how can you calculate? So skinning constant is equal to, for this electron, this one electron should be subtracted, because you are calculating for that electrons, that's why 1 electron should be subtracted. So 2 minus 1 will be there, so only 1 electron will be there. For n cell, you know contribution per electron is 0.35, so 1 into 0.35 for this one, and this is n cell, so this is your n minus 1 cell, this is also n minus 1, this is also n minus 1, means 4 minus 1 3 होगा ना, इसलिए. So this is your n minus 1 cell, and n minus 1 cell having 8 plus 6, so 14 electrons, and per electron contribution was 0.85, and this is your n minus 2 cell, n minus 3 cell, so having 10 electrons and contribution is 1. So in this way you can calculate sigma. So if you are calculating sigma, then you can easily find out effective nuclear charge. Let's see another example. Now we have to calculate effective nuclear charge for d electrons. Okay, so for scandium we can write first electronic configuration in this way: 1s2, 2s2p, 2 electrons, 6 electrons, means 8 electrons are there, 8 electrons are there, 3d and 4s2 electrons. But you have to know here we have to calculate effective nuclear charge for d electrons, means this one. So this one will having no contribution, means you have to calculate in this way, not in this way. That's why you have to calculate for this one. So we have to consider only these electrons, not this one. Okay, so we first can cancel out this one, then we have to subtract 1 from here. 1 minus 1 will be 0, so for no contribution for n electrons. So n electron no contribution, only we have n minus 2, n minus 3. So we have 8 plus 8 16 plus 2 18. So 18 and contribution will be 1. That's why we can calculate sigma is equal to 18 into 1 equal to 18. So Z star will be equal to this 21 minus 18, this 3. Then we will calculate Z star, means effective nuclear charge for 4s electrons of copper and potassium. See, copper having atomic number 29. So first write electronic configuration in this way. Then we have to calculate for 4s electrons. So first subtract 1 from here. So 1 minus 1 will be 0. So for no contribution for n electrons, now we will have n minus 1 means we have 10 electrons and 8. So 18 electrons are there for n minus 1 cell, and per electron contribution is 0.85. So we have to multiply this 18 into 0.85. Then for n minus 2, n minus 3, we have 10 electrons and contribution is 1. In this way you can calculate sigma and you can calculate Z star. Okay, and for potassium we have atomic number 19. So electronic configuration is 1s2, 2s2p8, 3s3p8, 4s1. We have to calculate for this one. So 1 minus 1 will be 0 for no contribution of this one. So for n cell there is no contribution. For n minus 1 cell means this one we have 8 electrons and per electron contribution is 0.85. So we have to multiply 8 into 0.85, this one. And for n minus 2, n minus 3 cell we have 10 electrons and per electron contribution is 1. So we have to multiply 10 is to 1, 10 into 1. So in this way you can calculate sigma, and in n you can calculate Z star, means effective nuclear charge. Now we have another question. Why violet color of this titanium hexaqua chloride becomes colorless when heated? This is actually coordination complex. Coordination complex means structure should be look like this. This is titanium and having 6 electron around a octahedron. This is octahedral structure. But when you heated them, then this H2O molecule will be removed out. So their coordination pair will be break. And for coordination complex we can see color because there is transition can occur from T to G to EG level. That's why we can see color. But when you heat this complex, this coordination will be breakdown. So there will be no transition. That's why we can't see any color when you heated this complex. Okay, this is the explanation of this complex. In my next lecture I will discuss these periodic properties. Thank you.